In this lecture, we'll be going over creating a ROS workspace so we can organize our development files. So before we do anything on our computer, let's get an illustration of what our file structure should look like. First thing to start off our development is to create a workspace directory. Inside our workspace directory, we will create a source folder, which is where our ROS packages we develop will be placed. Other folders which will also appear in the workspace folder are the build, install, and log folders, which will be auto-generated once we compile our workspace. Let's go ahead and focus more on the source folder, since that is where we'll be organizing our project contents. As I mentioned earlier, this source folder is where our packages will be placed. Think of packages like individual software bundles, generally used for a specific task, which can then be shared and distributed to other developers. Let's go ahead and see what our package structure looks like. Here we can see we have three main entities. The first is a source folder to put our raw C++ code in. There are also two files that are auto-generated when we first create our package. The first is our package.xml file, which contains information about our package, such as specific ROS dependencies. The second file is a CMakeList text file, which has specific instructions on compiling our package. This will give information to our compiler, such as if we created new C++ nodes, interface types that we may have created, and any other instructions related to compiling our package. It's worth noting that this is a very simplistic hierarchy, which we will generally use for this course, but also keep in mind within your package folders, you may also find folders for things such as Python scripts, launch files, custom interface declarations, simulation configuration files, and much more, so long as it pertains to the purpose of this package. We will go over these in more depth later in the course. Alright, now that you have a general overview of what our ROS workspace file structure should look like, let's go ahead and create our own workspace. Okay, we are on our Ubuntu machine and have our File Explorer open. ROS workspaces generally live in our home directory, so we would normally create a new folder by right-clicking and clicking New Folder. And if you follow a lot of tutorials on the ROS website, you would call it something along the lines of dev_ws or workspace. Now, in my experience, this is not very descriptive of what this workspace is for, and this will start to get unorganized if we want to make new separate projects. Instead, we will call this folder Workspaces. Now, if we go into our Workspaces folder, we can go ahead and make our actual project workspace folder. Generally, this would be named after a particular robot we are working on, but for the purposes of this course, I'm going to go ahead and right-click, New Folder, and call this workspace ROS2 CPP_WS. Just so we know, this is our workspace where we work on projects related to this Udemy course. Now we can go into our workspace and create our source folder. This is spelled SRC, and this is important for the build functionality we'll be utilizing later. Then we can go into this directory, and instead of creating a new folder for our package, we are instead going to use the ROS2 package create command in the terminal. So go ahead and open that up. I'll make this a little bit smaller so we can see our source folder. So I'll head over to our directory with cd. All right, so now in our terminal, we are in the same directory as we see here in our File Explorer. So now I can go ahead and run the ROS2 package create command, and I will call my package Udemy_ROS2_pkg, and then we will have to pass in a build type, which will be ament_cmake. If you are only going to be using Python scripts in your ROS package, you would set this to ament Python, in which case you would use a setup.py script to create your build instructions. But then you would not be able to pass in your C++ build instructions, whereas ament_cmake allows us to use both C++ and Python code. So I'll go ahead and hit enter. After running the command, we can see some text here. It comes to the screen, but we can also see in our File Explorer that our package actually got created. So if I actually go into this, we can see it automatically generated this include directory, our src directory, our CMakeList.txt file, and our package.xml file. So let's take a look at these generated files. So I'll go ahead and clear the screen. So I'll change into our package directory. And I can go ahead and open up these generated files, so starting with the package.xml file by calling code package.xml. So this will open up the file in our VS Code editor. So here we can see different fields to describe our package. I'll go ahead and zoom this in just a little bit. I'll go ahead and close this tab for now. Here we can see different fields to describe our package. You would generally want to fill these fields such as version, description, maintainer, and license before releasing your package to the public. We can go back to our terminal and take a look at our cmakelist.txt file. So that opens it up in a new tab. And after you trust it, just make sure that your language is set to CMake, which you can do at the bottom here. For those of you who have developed in ROS version 1, you can see that the default cmakelist text file has gotten much shorter and cleaner looking. We will edit this file later in the course to tell the compiler about many of the dependencies we need for our C++ code. So with that introduction out of the way, I'll go ahead and minimize this. And I'll minimize our file explorer. So we will be compiling our ROS workspace using a tool called Colkin. So I can open up a browser and head over to the ROS tutorial page on compiling packages. This will help us walk through the commands to install and configure our terminal environments. So I'll go ahead and put our terminal over to the left so that these are side by side. So I'll go ahead and scroll down and run this apt install command within my terminal. I'll go ahead and clear the screen for now. So you'll be prompted for your password. And we'll go ahead and hit Y and enter. All right, so that's gone ahead and installed. And so if we scroll down some more, you can see some explanations on utilizing Colkin, some of which I covered earlier. So I'll instead scroll down to the Setup Colkin CD section, which is right here. Here we see two lines which will source the Colkin CD command so that we can use it in our terminal, and to export the root directory for the command to point to our ROS Humble installation. So this writes these commands to our bashrc file so that it gets applied to any new terminals we start up. So I'll go ahead and copy that and paste it in. So I'll go ahead and clear the screen. And another helpful feature that we see right below is setting up Colkin tab completion. So this allows you to hit the tab key on your keyboard as you're writing out your Colkin build commands to help give you suggestions or autocomplete parts of the command. So I'll go ahead and run this line as well. Now, again, all these commands will not take effect until we open a new terminal or resource our bashrc file. So for the time being, I can restart this terminal. I'll go ahead and put it back. So now I will head back to our workspace directory. Even though we haven't created any new code yet, we can go ahead and build our workspace. We can do this with the Colkin build command. Be sure to run this command in your workspace folder and not within your package folder. So I'll go ahead and run this. All right, so our workspace has successfully been built. And if I actually go ahead over to the File Explorer, and I go back to our workspace, we now see our build, install, and log folders. Now, to include our package in our terminal environment, we need to source the setup.bash file in the install folder. Now our terminal is aware of our workspace, including our newly created ROS package, and we can check by running ROS2 package list. And so this gives a full list of all the available packages to us, but most notably is the one we just created, which is right here, our Udemy ROS2 package. Congratulations! You've successfully created your very own ROS2 package. But let's review what we learned. In this lecture, we took a look at ROS Workspaces. So the first thing we did was create a new workspace and source folder so that we could create our new ROS2 package. So we did this using the ROS2 package create command, followed by the build type, which we configured as a ment CMake. Then we took it a step further and compiled and sourced our ROS workspace to our terminal environment. So we did this with the Colkin build command, and then sourcing our install setup.bash file, we were able to use ROS command line interface tools and see that our package was indeed recognized by ROS. Now, this was just a quick intro to get our ROS2 package up and running, but we'll be covering more information about compiling and sourcing our ROS workspaces in future lectures.